Hi, this is Olajide from CTF Security and welcome to another interesting video in the Hackthebox series. In today's video, we will be tackling Error, a Linux-based machine packed with web exploitation, insecure PHP wrappers, and a powerful privilege escalation path. We'll start by uncovering hidden subdomains and exploiting a remote code execution vulnerability via protocol injection. Then we'll gain root access by injecting a reverse shell into a custom compiled payload and replacing a scheduled binary that runs as root but is writable by our users group. So without further ado, let's get started. Alright, welcome back to the channel. Currently, we are on the lab information page and we currently have our target IP. So we're going to grab that and quickly run the Nmap scan on the IP address. So I'm going to go to a new tab and we can quickly use the CD to change directory into documents. We're going to change directory to YouTube. And we can create a new directory called error. Okay, so we can run the nmap, the script scan, as well as the version scan on our IP address, and we can also save this into a file called error_scan so that we can review the output later. So this is going to take few seconds to run. So while we're waiting for the scan to complete, I'm just going to take the IP and let's head over to our browser and take a look at what we have on the interface. So you can see that we're actually getting no internet error. So I'm guessing the issue is because we've not redirected the domain name in our etc/host file. So we're just going to wait a bit to see if the Nmap scan will be able to figure that out for us. So let's head back to our scan. Okay, it looks like our scan is done and we can see from the Nmap result that we have a web server on the port 80. We also have the FTP port open on port 21, which is running the VSFTPD 3.0.5. So I probably checked that out, but we're not going to be doing that for today's video. So what I'm going to do is I'm just going to take, before we proceed, you can also see that we have the 778 port, which is actually filtered, and you can see indications that we are running Unix Linux. So let's just take this again and let's see, probably I have my proxy. Okay, so I have my proxy set to Bob, so let's just switch that back to disabled. And then we're going to try to access the IP once again. So you can see where the IP is pointing us to error.htb. So what I'm going to do is head over to my terminal and let's use sudo sublime, which is a text editor, to open etc/host file. And with this, we should be able to modify the host file by appending our IP address along with what we are seeing on the domain. So let's quickly paste that in there. So we're going to do away with the protocols. I'm going to save this. So now when we go back here and refresh, this should work. Okay, great. So we are currently on the home page of the web application and it says error design, and we have some couple of menus: the services, the about us, portfolio, client, teams. So there's nothing much I could actually get hold of here. So the next thing we're going to actually do is to perform directory fuzzing, but that is not going to get us anywhere. So I'm going to perform subdomain enumeration first, then we're now going to perform the directory fuzzing. So to do that, I'm going to just head over to my terminal. I could probably clear what we have here, and I'm going to be using a tool called GoBuster to perform the subdomain enumeration. You can as well use FFUF. I think there are a couple of other applications or scripts that you can use to perform the subdomain enumeration. So to do that, we're going to use GoBuster vhost, and we're going to specify the user, and the user is going to be HTTP, not really user, I'll just take it as the host. So it's going to be error.htb. Okay. We're also going to specify the word list. I'm going to be using I think, if I'm correct, locate common.txt. This is from Avesta. This is from wfuzz. This is from derb. So I'm just going to use this one. So let's head over here, and we're going to paste the path to the common.txt word list, which is what we're going to be using to force the domain names. Then we could also specify to append domain, and the thread could be maybe 100. We can set a timeout to 5 seconds. So I think this should work. Then we can execute. So it looks like we found some things. Okay, good. You can see that we got some couple of 400 status code, but one particular subdomain that gave us 100, which is okay, is the file.error.htb. So what I'm going to do is to modify the sc/host file I opened earlier, and we're also going to append that subdomain to the list of domains, so I can minimize that out. Now if we go and open up a new tab, I think we should be able to access the file.error.htb. And you can see what we have here. We have options to manage files, upload files, update, security questions, sign in. If you access the Wapalizer on this page, you will not really get much information, just the programming language that is used by the application, which happens to be PHP, and we have the operating system also. If you click on each one, you see that it requires us to sign into the application with credential, which we do not have presently. You can as well click on upload, same thing. You can click on update security question. You also need to log in. You can also click on, what did I click on? I think that should be sign in. So it says sign in as a different user. So we need an account. But unfortunately for us, we do not have options to create or register an account to be able to access the internal structure of this application. So what we're going to do is to force this particular subdomain to see if we can actually get something different, maybe a registration page that we can work with. So to do that, we're going to head over back to our terminal, and we're going to be using FFUF for this. So sorry, I beg your pardon. We're going to be using the Dirsearch for this. So it's spelled DIR, then search, then we're going to specify the name, which is going to be file.error.htb. And if I run this, we are expected to force the different directory on the subdomain. So I think it has started already. Our target is file.error.htb. So we're just going to wait a couple of minutes for this fuzzing to complete. So it looks like we hit a 301 status code, which happens to be the /asset. And I'm guessing this will likely redirect us to the login page, but we could actually try this anyway. Let's see, what do we get if we append /assets to the back? Okay, so we got 403 actually, which is forbidden. Okay, so let's go back to our fuzzing, and I think we got one already. We got /download, which will probably also redirect us to a 403, I guess. Oh, actually this redirected us to sign in, so we can access the /download, or else we sign up an account. So let's head over back. Okay, so we got other directories. We got these /images, which will likely redirect us as well, because we have this to be 301, probably to forbidden. Let's just try that out. Okay, yeah, you can see it's to forbidden. Logout will probably work because this is 200. But unfortunately, we are not logged in already, so this is probably useless to us for now. So I think I found the register.php. So while the scanning is still going on, I'm just going to grab this and let's append that to our subdomain. So this should be able to give us the registration page. So you can see it, we have user registration. I can actually try this by using R007 to register an account, and I can submit registration successful, and is asking me to sign in my account. So let's just enter R007 as the username, R007 as the password, and this should take us to the dashboard. So we have an idea of how the internal structure of the application looks like, and you can see that I have options to manage files, which is what I am on currently. I can automatically delete my file after a certain minute. You could actually increase this. I have options to delete file as well. I don't have any file currently, and I can also reset security questions, which is kind of interesting, and I can actually return home. So this is options to upload files, update security questions. So I can put a username. So for this application to allow me to be able to specify a username, I want to reset the security question. So probably if I can gain a higher privilege account and put the username here, and if I have access to the security question, I could be able to reset this particular I could be able to reset the account security questions. I think those are the few options that we have. So what I'm going to do is, let's just try to upload a dummy file. Do I have any file? Just light file. I don't know what this is, but password.txt, one for all. I think this is a JPEG file. Hash.txt. I don't even know where this is from. Can we go to the document directory inside the HTB? Let me just upload this PHP Wrapper shell. So I'm not going to modify anything. I'm just going to upload it. Okay, so we can see what we have. So it's actually giving us a download link to that particular resources that we uploaded, and it gave us an ID 819 here. So that means we might probably look for an IDOR vulnerability here by actually trying to force the different IDs within the application to see if we can discover other files. And to do this, what I'm going to do is to create a sequence of numbers. So if this is 8,000, I could actually do from 1 to 10,000 and then use it to force the application to see if I can discover a file that is already on the application, even though we are not seeing anything from the current account we are logged in as. So to do that, we will quickly, I think I got some things here. So let me just keep it in case I need to revisit this few of this one. Let me just open a new tab. So let's call it error HTB Hackthebox. Okay, so these are a few of the subdomain that we got earlier. So we're trying to create a sequence of number, so we can use the command seq and we can specify a range of 1 to 10,000, and we can redirect it into a file called id.txt. So id.txt will now contain a sequence of number from the range of 1 to 10,000. You can actually try to cut that to see the content. So you can see it's just sequence of number that we want to use to pause the ID. So what we're going to do next is, let's clear the screen, and we're going to use FFUF, and we're going to specify the URL. So let's go grab what we have here. We also need a cookie. I don't think we have. This could have been very much easier on Bob Suite, but I don't just want to use Bob Suite for today. So let's go to applications. Let's go to cookies. I think we found one. We found the session cookie. Okay, so we found a session cookie. I'm going to head back into the command here. So this has to be in quotes so that the special character will not break the command. So remember, this is what we want to fuzz. So this is going to contain the word fuzz, and then we can specify the word list. The word list is going to be the sequence of numbers, which is going to be id.txt, and then we can specify the header, which is the cookie. Let's just put this in code, and I'm going to specify the word cookie. I spelled wrongly. I can specify the PHP session ID, and I think I'll need to paste that in here, and then I can now specify equals to the value of the session ID. So let's quickly grab that. Okay, so I think we did that correctly. Let's just run this and see what we got. Okay, so we keep getting the same 3161. So what we can do is, let's bring back the command and we can use the forward to the value of the 3161. I think that should be able to figure it out, so that we go for something other than these particular words. So I think we're good to go. Okay, so we got 54, we got 150. What else? So while that is coming up, let's just grab this 54 and let's modify this. I don't need this anymore, so let's modify our ID to 54. Oh, I don't think we can. Okay, can I just copy it and access it separately and change this to 54? This is nice. So you can see that 54 actually contain a file called site backup 300824.zip. So that's probably an indication that the access control of this particular application is not actually secure, because I'm very sure that the new account I created does not have this site backup file. So it's probably a file from other users' accounts on the machine, probably from the admin account also. So if I go back and see our scan is still going on, let's see what is contained in 150. I'm going to modify this and just have 150. So we have another file called signing.zip. This is almost done as well. Okay, so I think this should be the file we uploaded. So this should be my PHP file. So you can see it. We have the PHP reverse shell.php, which was the file I uploaded. So from here, what next? What can we actually do? So I'm going to download the, I don't think I will need the signing.zip. So let's go with the ID number 54, which happens to be the site backup file. So let's download that. I'm going to keep. So I think the download has finished. So let's open up the directory and I'm going to grab the site backup file. And let's head over to documents. Let's head over to YouTube, error. We're going to paste it in here. And if we go back to the terminal, I think we have our site backup file. So let's quickly unzip that. We might want to create a new file so as not to mix our file up with the error scanner in the id.txt file. So let's create another file called error. So let's move site backup into error. Good. So now if we go to error, we should have our site backup file. So I can run the unzip site backup, and this is going to extract the content of the site backup file. So you can remove the site backup. I don't think we'll be needing that again. So from what we have here, you can see that we have some download.php files, index.php files. So I'm guessing this is the file structure of the file.error.htb system. So what I should be doing next is trying to access some of these files, like the download.php file, to review it for any security vulnerability. We also have the file DB. So I'm guessing this is the database of the application. So from here, what I'm thinking is, if we're able to access the user account database files or the database table on this particular machine, we'll be able to probably reset some of the security questions like we saw from the interface of the application. So let me probably show you what I'm talking about. So if we go back, let's say file.error.htb. So we have an opportunity here to log in using security questions. So if we're able to do that, we would be able to bypass the authentication put in place on this application. So first thing I want to do is I want to use, since this is an SQLite database file, so I want to use SQLite 3 to open file DB. So I think that should drop us into the SQLite shell. So from here we can do .tables, if I'm correct. And you see that there are two tables on this application. We have the files and we have the users. So I'm not really interested in the files. So what I probably want to check out is the users table. So I can do select everything, that is select all columns from users. So I can end this using a semicolon, and you can see that we have the IDs of different users, we have the list of all the users, and we have the hash of the admin account, which has some characters appended to the end. We also have Veronica, Yuri, John, Ethan. So we're unsure if these are legitimate users on the machine, but since they exist in the database, we'll probably review them. So what I'm going to do is, let's copy this and add it to this sheet right here. Now the next thing we're going to do is probably to crack the user hash, but it is not properly formatted for John to crack. So we have other informations here. I don't know what this is, Maria, Oliver, Ottawa. So if we want to actually know what these are, we'll probably view the schema of the database. So if I'm correct, let's see, it's probably a while. I'll just do .schema. Okay, good. So we can actually check schema for the users table and for the file table. So the schema is, we have a username. Sorry, the ID is the first thing. We have the username, which is this. We have the password, which is the hash up till this point here. And we have auto delete file. We also have security questions. So I'm thinking these are the different security questions, and sorry, the different security answers, which is the Maria, Oliver, and Ottawa, which is security answer 1, security answer 2, and security answer 3. We also have for the file, which is the ID, the path, and others. So we could use the same command we use to view the users table to also see what is inside the file. So we just need to replace this with files. So you can see that we only have one file on this particular backup database, which is the ID of 54. This is the path to that particular file. So the next thing we're going to do is to extract just the username and the hash only, instead of having everything just like the way we have it now. So to do that, we're just going to use some filtering, which is select what is the username again. This is the username, so let's point that out. So instead of selecting everything, we're selecting username, and we want to format it using the John style. So, and you can see that what is separating the different column is just a pipe symbol. So we can also specify a column at the middle, because that is how John likes it hash to be formatted for cracking. And we can also specify the pipe symbol and then the password. Where's the password? This is the user password, and I'm going to paste that in here. And where are we selecting from? So it's probably from users table, and I can execute this. So you can see that we have it properly formatted now. So let's take that over to this point here. So this is the formatted hash, and we'll also need to, let's just exit this. We might probably come back there. Create, so let me go one step back. So we might also need to create hash file where we're going to dump what we just extracted, and then we need to also locate raw queue, because that is what we're going to use to crack the hash. So I'm going to specify John, the word list equals to, then we want to specify the path to the word list, and then the hash file. So this is going to take few seconds or probably a minute or two to crack the hash. So I think we got one password already, which is Eric account, which happens to be America. That's the password. So let's just wait a minute if we can get one more. So I think we got Yuri as well. So we have successfully cracked the Enri account and Yuri. So unfortunately, there's no SSH port open on the machine, so we can remotely connect to the machine via the SSH. So, but there's FTP, but we're just going to access that later. So first thing I want to do after cracking these hashes is, let me just grab the password we currently have. So I'm still going to leave that to run. So let's go back. I'll probably use this other tab. So let's go to document /HTB, or rather /YouTube/error. Let's see what we have. Okay, so we have the error directory, which contains the backup files. So you can see that we have a particular PHP script called security-login. So I'm going to grab that, and let's try to access that. That's wrong. So it should be file.error.htb / security.php. So this is expected to work. Or I might need to append HTTP to the back. It's taking a hell lot of time. security_login is currently not accessible. Oh, somebody's trying to reset the machine. That's bad. So we'll just give it a few seconds and okay, I think it's back. So if you've forgotten your password, you can log in by answering your security question, which is interesting. And remember, on the database file, if you can remember, when we extracted the credentials, that's the username and password, we also got the database schema, which pointed that the users table contained security answers 1, 2, 3. So I'm getting those are the 3 questions, and the answers are for admin EF01CAB31AA is Maria, Oliver, and Ottawa. So I'm guessing this person hasn't reset this, but if the person has reset it, then we'll need to probably reset the security questions. So let's grab that, and we're going to put Maria here. Oh no, sorry, that's not what's supposed to be there. So we should have the username in there. So aside from the username, the first security question answer should be Maria. And then, what was the name of your first pet? That's Oliver. So let's put that in here. And last question is power. So I'm going to log in. So you can see we got incorrect answer, please try again. So we can actually use the default security answers we got from the database. So what we need to do is to look deeper into the files that we have. If you look, you see that we have something called, where are you, reset.php. So I can try to access that. So this is asking me to log in. So I hope my Azure 07 account is still active. Oh, I think the reset has wiped the account. So remember, we could use the register.php to register a new account, or instead of logging into my account, I can even use the Yuri account or any other account. Let me just stop this. I don't think it's going to see any other thing. So let's use Yuri account, for example. Just log in as Yuri, and then let's have Yuri's password. User, okay, this is registration page. Sorry about that. I intend to go to the sign in page. So instead of having to register another account, let's sign in as another user. So let's specify Yuri and the password. That's crazy. Yuri. Okay, the password for Yuri is Mustang, not America. Okay, good. So we are in Yuri's account. If I modify the value here to reset the PHP. So our session should be able to update. So let's see, who do we want to research the account? I want to see if Yuri would be able to reset the administrator account. And I'm just going to change the security question to admin. Hopefully this is going to work. Wow, so it works. So it means that a low privilege account like Yuri can reset an admin password. So what we're going to try to do is return home and try to log in using security question. So now we have admin and we reset the admin password, the admin security questions to admin. And I think we should now have access. So you see, these are the two files we saw earlier, which has the ID of I think 54 and 150 respectively for the site backup and the signing.zip. Okay, so currently now we've successfully gained access to the admin GUI. So what do we do next? So what I'm going to do is I'll probably clear the screen or just leave this in case we want to review any of this file. So I'll probably use the FTP to access. I think we do have the IP here. Yuri at this. So we need to supply our password, which is Mustang, and we're going to paste this. So I think we logged in successfully. So let's see what we have. We have Apache 2, we have PHP 8.1. So let's see, these are directories. cd apache 2 underscore conf. So let's see, we have file.conf, port.conf, default.conf. These are just the configuration files. Is it possible to go back? And now let's see into these PHP configurations. And let's see what we have. Okay, so we have dom.so, exif.so. So this .so is actually called shared object compiled binaries, and they are just like different compiled binary on the system that we can actually use outside the default installation of the application. So we noticed earlier that we do not have SSH on this machine, but we could run SSH internally within the application using this SSH2.so. So we could pick this up, or I think I already have it somewhere here. So if you go to php.net under the manuals and you go to PHP wrappers, you'll be able to see what you can do with the SSH2.so on the application. And these are few of these commands. So we could probably run ss2.shell using that SSO because it's present on the machine. And we can also run the ssh2.exec and probably be able to pass in the username, password, and IP, and then execute a command remotely on the machine. And it is mostly attributed to things like the fopen, allow URL fopen, and other functions within PHP. Now, if you go back a bit and we try to access, let's use Sublime to view what we have on PHP. So in order not to waste time, let's put this on Copilot as well. So let's tell Copilot to review this download.php for security vulnerability. So probably to be able to point one or two things while we look at it manually. So already it found something. So it says the fetch, that is the SQL database which is fetching everything from file where file ID is this, is probably vulnerable. Relying solely on it is insufficient, blah blah blah, but I don't think that's what I'm trying to search for on this video. We also see another thing, that is the path transversal on the file slash wherever, improper file access control. So this is what I'm looking for. So if you go to the script, let's see what we have. Yeah, I think somewhere here on line 58 it says beta currently only available to the admin showcase file instead of downloading it. So it says it has a conditional statement that says else if the parameter is show and it's set to true, that is if the show is set to true and the error user is equals to 1. So I'm thinking this is the ID is trying to specify, which is the admin. So if you're accessing it and your show parameter is true and the error user is equals to 1, which is the admin user, is going to execute this particular command. So let's focus on what is actually happening here. So I can tell the review this. So it's performing code review on that particular section of the code. So we have issues with unvalidated format parameter. So it's saying that the format parameter is not properly validated, and the issue is that it allows different PHP wrappers to be injected into the application. It does not really reject any specific PHP wrapper. So we could actually fix this by whitelist to allow wrappers, a specific wrapper like maybe the file wrapper or the HTTP wrapper. It also says it has weak admin check, so because it's actually validating using an ID directly. So we can use a robust role-based access control system to use maybe session instead of just specifying the ID number. What else? It says recommended. That is, it's just actually rewriting the code, but fortunately we don't want to fix the code. What we want to do is to exploit this particular code. So what we can try to do is, since the format parameter is, I can tell, okay, kindly give me the request an attacker would probably send to abuse the format parameter as ID1, so that we can get an overview of how we can structure the SSH2.so we saw on the machine. No, this is not what I want. It's not what I want. So it says this allow an attacker to inject arbitrary wrapper stream like the PHP filter stream, the input stream, the data, as well as HTTP. Okay, so what if, okay, so sorry about that, I think I clicked on the wrong thing. So what if we want to execute a command using the SSH2.so we saw earlier? Okay, so it's saying that if we're able to pass a payload through the download.php and we set the, no, this is not the ID. I'll probably change this because it has to be a valid ID on the system. So show is equals to true, and then we can now pass this as the format. Okay, I think that makes a lot of sense now. But we'll need to actually look for a bash reverse shell to be able to execute instead of just connecting to the host. So what I'm going to do is I'm going to review this. So let's verify we still have access currently. Okay, so I think our session is still active. And let me just, I think this is the admin account. Can I upload something, an ID which I'll just use to pass my payload? So it can be anything, maybe a text file. I think text file will be better. I don't know, is this an heavy file? Just 500 and this, so this should work. Password.txt. So we have an ID of this. So let's grab this. And review our payload. So let's see. This is the ID of 7680. And let's go back a bit. We've gotten an ID up until this part here. And show equals to true, format equals to SSH2.exec. Then we could specify the login credential. Remember, we also have an account for Yuri. So let me try Yuri instead. And then what is the Yuri's password? Yuri's password is Mustang. So let me just paste this in here. So we'll probably use the IP to be localhost since we can't remotely connect. There's no open port on it. So it's going to be 127.0.0.1. And then we can now specify maybe our reverse shell. So let's execute bash -c, or let me just quickly get that from somewhere. So let's say rev shell. So let's see. So we want to execute bash this, and then let's have this here. TCP, we'll still need to verify that to change that. So I think I've removed this one. So what's my IP? 10.10.14.80. That is going to be 10.10.14.80. And I'm going to use port 444. I think this is it. So I'll probably need CyberChef to perform some URL encoding, but I think this command should work. So what we need to actually URL encode is from here, I guess. URL encode. Where are you? Mm, 10, 10, 14. Yeah. So let's hope this is going to work. Copy. So let's try to get this one and up until this point here. Also, end cards. We need to listen on 444. So I think we are good to go to test this. So let's take this one and let's see. So this is trying to download. Who am I currently logged in as? I think I have to relog in because the ID has to be 1, which is for the user's account. So let's try to log in into. So I think this is the ID. I think I reset it to admin the other time. Yeah, so we're logged in. So let's close this. So I think our session should be able to manage this. Still the same thing. Still downloading. So I think we're getting some things wrongly. So let me just review our command one more time. So we have bash -c. We have code bash is greater than and def 10.14.80 444. So let's try to see. Probably it's appending something to the end. So let me just try and break this. Since my quotation was not even complete, so I opened a quotation, I didn't close it. So maybe that will be better now. So let's review that on the let's encode special characters. Hope there's no plus, so let's see what happens next. Nope, sorry about that. I should be on this point here. Okay, I think we have something. Okay, yeah, so we gain a shell. So basically what I did was URL encodes the different special character in our payload. So we gain access to the Yuri account right now. So if I say who am I, well, Yuri, if I say ls, we have nothing here. So I think we gain access to the wrong account. cat/etc/password. So we have Enri. Yuri has an ID of 1001. Okay. Eric, so I'm guessing Eric should be the users we should be after. But nevertheless, is there any other thing we need to do before we exit this user account? Okay, so let me just exit. I'm going to open that listener again, and we might need to modify the account name. Let's change this to Eric, and let's change this to America. So let's go ahead and try again. So we gain access to Eric. So ls. So we have our user.txt. So cat user.txt. Oops. Cat user.txt. So we have our user.txt file, which is the first phase of capturing this particular lab. So I'm just going to drop that here. This is user.txt. So the next thing we are after is how can we escalate our privilege from Eric's account into the root account. So we've already seen that we have two users here, Yuri, and Eric happens to be the ID 1000. So I can check. I'm currently logged in as Enri. My GID is Enri, my group is Enri, and I also belong to a group called devs group. So what I can do is to find all users, or rather, let's just see something. Let's find all user. So what I can do is find from the root directory user, that is files that are owned by root, and the group is devs, and the type is file, and we can redirect type is file, and we can redirect error into /dev/null. Let's see if we can find something. Okay, we found two files inside the opt directory, and this happens to be in the AV directory, so I'm guessing this is an antivirus, and inside a periodic check directory, and the file name should be monitor. So let's try and access cd/opt. Let's see what we have there. So we just have a file called AV, cd AV, a folder rather, not a file. And inside that we have periodic check. So what do we have inside the periodic check? We have two files, monitor and status.log. Let's check. Are they directory or their files? Okay, there happens to be file, and you can see that they are owned by root, and the group is devs, which I belong to. You can see where I actually verified that I belong to the devs group, which is here. So we can also run file. We know the other one is status. So I can do cat status.log, see what it contains. I hope somebody is not trying to reset. Okay. So this is some kind of log from, I guess, maybe from this monitor file. So what I can do is also check file monitor to see what kind of file this monitor is. Maybe it's a binary file or whatever. So we said it is a 64-bit LSB Pi executable version 1, dynamically linked. So I'm thinking this is some kind of binary file. So we can actually verify that. Let's see what this has to say. Okay, so it says it is a 64-bit binary using little endian bytes compiled as a position-independent executable file. What you can do with this info, check if the binary is Pi dynamically linked, good for ESLR debugging. If you're analyzing this for reverse engineering, malware analysis, or system profiling, and I can help guide. So I don't think that is what I want to do right now. What I can do is, can we run the file? Can we do, before I run it, so I'll probably bring the PSPy in, which is a tool that can be used to monitor process on a Linux system without needing root access, because currently we do not have access to root, and we could not tell background process that will run whenever we execute the monitor binary file, which we just saw earlier. So I have a file called PSPy. Let me see if I can actually locate PSPy 64. So it's just like a process monitor. Can I go back a step? CD as well. CD HTB should be somewhere here. So this is the file. So I can start a Python 3 http.server here. Then I'll be able to download this file to the remote machine. So on the remote machine, we can do wget. Let's see if we have something like that. Okay, yeah, we do. So we can do wget http 10.10.14.80, which is my IP address on port 8000, and then the name of the file is PSPy 64. So we can add and so that it does not break the shell after download. So let's just have that. It's downloading, almost done, I guess. So I think we are done. So now we have the PSPy. I think I should be able to do change mode +x PSPy 64. Yeah, I think we've done that. So before we run it, I might want to do, okay, so let's just run it. Let's say PSPy, or rather we can do /PSPy 64, and we make sure you append the and as well, so that we can see how these processes are running. So it's running. So while it's running, we can still use the terminal. That's the idea of adding the and. We can use it to run Where's the monitor file? ./monitor. Okay, so it says permission denied. So I'm thinking we can't necessarily run. So it means if this monitor is actually executing, it should be maybe as a cron job. So I think we have some information from the what is it called? We have some information from the PSPy, and we have something, I think process 5219 executing bin/sh on root initiate monitoring.sh, and it's redirecting it into the log file. Okay, so that explains why we are seeing the status.log. We also have another process running --c to initiate the monitoring.sh object copy. So I'm thinking this is some kind of signature validation from the monitor file. So I'm thinking this application or this antivirus is checking the monitor binary file for a specific text signature to verify the authenticity of the file every point in time, and this is executing automatically. To have a better overview, I think best thing I want to do for now is to grab this, and we can review this using Copilot as well. So if we better understand how the background processes are running, so might be able to understand how we can structure our privilege escalation payload. Why is this taking time? Can I use something else? Cloudy.ai. Or using my network. Still running. Okay, I think it's back here. Well, let's see if we can get a response from Cloudy. So it says this looks like a process monitoring output from Linux system showcasing command executable by root. It says it extracts a signature using the object copy to dump the text_sig section from the monitor file binary. It passed the signature data using OpenSSL, and then it validates the certificate field using the organization ERAC Inc., the email. Not really interested in that. It runs the monitor, which is executing the opt-av periodic check /monitor if validation passes. So that is the only situation where it executes this. If it successfully validates the signature file, then it clean up the signature.binary file, so which is interesting. Observation: since you are seeing this as a user, Eric, a few things stands out. Root own script with predictable timing every minute. Temporary file creation. So the idea here is, if we're going to be, since this particular monitor program is being run by the cron job, so if we're going to be abusing that particular file, because the file is actually owned by root and it belongs to the group devs, and we are one of the member of the dev groups. So if we're going to be abusing that file and modifying the file, or maybe replacing, we might need to, or we would need to validate the signature, like the way the application is verifying the signature by extracting it using this object copy. So we need to also do that on our payload. If not, the payload will likely fail. So we're just going to be creating our own payload, something to replace the monitor script with. So let's do that on a new tab. I'll just leave this, or let me just close this for now. So let's do Sublime. Let's call it maybe Backdoor.c, because we need to compile it. As usual, include stdlib.sh or .h rather. Want to add e here. Then int main then we want to execute system, not forgetting, I think we ran something relating to bash script recently, so let me just grab that and I'll paste it here. We want to execute bash, but we have to also specify the path, which is being /bash, and we want to use it to run the command. Let's have this in quotes. Then everything will end with a quote. So I think that should be good. We're going to return 0. So I might want to validate this just to verify that there's no error. My network is actually bad. So I can see you're working on a reverse shell in C. About this code, this creates a reverse shell that connects to this. Of course, I know that important consideration, the validation script check for error these days, you will need to craft a proper DER encoded ASN structure in the .text section. The object command extract this specific section, so it needs to exist and properly formatted. Okay, so we can use object add section. But before we do that, let's make sure that our IP is correct. Then this will probably be 80, as you can see up here. And we're going to use a different port for this, maybe 4445. Probably. I'm going to save this. And let's open up a new listener. So let's call it NLVP 4445. All right, good. So the next thing we want to do is to take this to the machine. So let's start our web shell once again. Let's verify we have it. So I think this is the backdoor file. Let me move it to error. Move backdoor to error. CD error. Okay, so let's start the server here, and then we can download it here. wget. Oops, this is going to cause problem. So we need to find a way to kill this. So let's call it jobs. jobs. Okay, so what if we kill job 1, kill recent 1? Okay. I think we should now be able to use wget to 10.10.14.80 on port 8000 / backdoor.c. Hopefully this works. Okay. So let's move backdoor.c to /temp cd /temp. So we have our backdoor.c. So the next thing we're going to do is to compile it. We're going to use gcc static. Then we need to specify the file, which is going to be backdoor.c. Or rather, let's just say, let's call the name, let's say static backdoor, or we can give it the name monitor_backdoor. Then the file we can point into /temp /backdoor.c. Okay, it should work. So the compilation is taking a while. So it says it couldn't find. Okay, so let's modify that. Let's say gcc static /temp /backdoor, and let's have /temp /backdoor.c. gcc static. Okay. Why are we having gcc temp monitor backdoor.c? Cannot find temp monitor backdoor, no such file. Okay, so instead of this, I don't know why I keep having, let's remove backdoor.c, and what was the content? Let's have cloudy. Give me echo command to create this backdoor.c file inside temp directory. I don't know why it keeps failing initially. Okay, so let's try this one. Okay, so it has been created. Oh, I think I know what the problem is. I didn't specify the name. Oh, that was my mistake, not the script. So let's put static, and we can specify the name the script is going to bear, or the binary file is going to bear. It should be inside monitor, then inside temp, the name should be monitor underscore backdoor. Okay, and then the file we're pointing to that we want to compile should be temp/backdoor. Let's see. I think this should work. Okay, I think it did. So the next thing we need to do now is to extract the signature, the text signature that the previous script was validating from the monitor file. So to do that, we can say object objcopy, and we can use the dump section .text underscore sig. I think we had something like that. So let's see. Sig equals to, let's point it to a location where we're going to extract it to, and which is in the temp directory, and we're going to specify the full path to the monitor file we want to extract the text signature from, so which is inside the opt av/periodic check /monitor. So I think it should work. Okay, it failed. So maybe I misspelled something. Okay, let's have that again. So we're going to have objcopy, and we're going to dump section .text or rather, let me just pick this instead of having to stress myself of the error. It's like taking a while. Means objcopy cannot find this particular file, av periodic check monitor. Well, that looks like the original part. Okay, so let's just go ahead. Text underscore sig equals to /temp/sig/ this is the actual part. /monitor checks. Okay, I think the problem is the S here. We didn't add the S. Let's see what we got now. So now if we do ls, we should have the signature file. Let's see how it looks. Okay, so this is the signature file. So the next thing we have to do is to inject this signature file into the backdoor file we just created, which is the monitor backdoor file. So we're going to use the objcopy, and we're going to specify the add section .text underscore sig equals to /temp/sig, which is where the sig is, which is the location where the sig or the signature is, and then we're going to specify the temp/monitor underscore backdoor, which is the file. Oops, did that work? I don't know if this is going to break it, but let me just execute it to see if it works. If it didn't, then we have to add the signature once more. Okay, so I think we are all set. The listener is on. We have successfully added the signature to our backdoor compiled file. So I think the next thing will be to replace the binary. So to replace the binary, we're going to have to copy the /temp/monitor underscore backdoor to the full path, not this one. Yeah, this one. Okay, so all we have to do is to wait a few seconds, probably a minute or less than a minute, to see if we are going to gain a shell. So while we are waiting, we can verify what is on this part here. Okay, so I don't think it's supposed to take that long. So I'm thinking the last command we executed didn't take effect, which is this one. So let's see, can we... Let's see, what is it? Not copy this one. Monitor copy. So let's see. Okay, I think this is where the issue is. So it says the temp, this can add section to this unrecognized file. So let's see what we are having. That error. Okay, maybe the file failed. Okay, so let's see what we can do. Let me just put this one here. The first point was we created the backdoor file. So let's remove sig. Let's remove monitor backdoor. Let's remove backdoor .c. I think those are the few things. Oops, I think I'm the cause of my problem. This is another problem. I think this should be 14. But I don't think that was the reason why it failed. But I'm just going to fix that anyway. Let's see. So cat backdoor. Let's see. So it has been fixed. Okay. So aside from that, we also, after creating the backdoor file, we compiled it. So after compiling, we extracted the signature. The object copy dump section the text temsig / this monitor checks monitor. So I think this is what we needed. Okay, so after extracting, I think this is where the problem was. We now injected this. Okay, to, let's say, object copy add section dot text underscore sig dot text underscore sig equals to /temp /sig. Then we have this /temp /monitor underscore backdoor. So we have the backdoor, we have the monitor underscore backdoor, we have the sig, and let's see if this would work. Okay, didn't fail. Then the last point was to copy /temp /monitor underscore backdoor to /opt /av /periodic -checks /monitor. So let's hope having to retrace our steps will fix the problem. Yeah, so I think we gain root access, and we gain access to the root. We have the root.txt, we have the clean monitor, we have the answer.sh. So what is this? This is none of my concern, so let's just start root.txt, and we have our final flag. TXT. So you can as well stabilize the shell, check out the different scripts within the machine and other things. So we found our final root.txt flag, which is an indication that we have successfully compromised this machine. So guys, that will be the end of today's video. If you've learned one or two things from this video, make sure you like, subscribe and share. Your support helps me create content that you love. Thank you for your time, and I'll see you in the next video.